All right, there's the mental math for you. I showed some of my work, which makes it not look mental, but it was to help you see what was happening in my brain, which could be scary to some of you, but I showed it. There you go. All right, so this means plus positive 50. So 50 wins is going to be a positive, and when you take 27 away from 50, you get 23. This one, be careful, because what we get is 10 times 10 to the, 12. But remember, this is not scientific notation. True scientific notation would be 1, here I'll even show it better, 1.0. So we have to move the decimal point that was here and move it over, so what we get is 1.0 times 10 to the 13. You're probably going to hate me for this one. All right, this one, if we take 80 away from both sides, we get 80 equals 4y. So 4 times something equals 80, and that something is 20. Okay, convert. Remember, the conversion was divide by 5, multiply by 9, add 32. So if we divide by 5, we get 3. 3 times 9 is 27, plus 32 is 59 degrees Fahrenheit. Okay, this one we do 9 times 1 and 9 and 2/3 of 9. So 9 and then 2/3 times 9 is 6. So 9 plus 6 is 15. Okay, 25% more than 80. So 25% of 80 is 20. It's a fourth of 80, right? And 20 plus 80 is $100. Okay, 15% of basically 50. Okay, 10% of 50 is $5. So if 10% is $5, 5% is $2.50. So 10% plus 5% is $7.50. Okay, hope you enjoyed that. Now we are going to get to use some mathematical tools. All right, this is all about estimating angle measures and how to estimate how big an angle is. And the book suggests using a clock that we all know as a way to estimate how many degrees are in an angle, okay? So we can build a mental image of a protractor from a mental image we already have of the face of a clock, okay? So the face of a clock is a full circle, which is 360 degrees. It's divided into 12 numbered divisions that mark hours, right? From one numbered division, there are, it's 1/12 of a circle. Okay, so if these are each 1/12 of a circle, we know that basically if we drew a line between this point, if this was an angle, see what I'm saying? That would be 30 degrees, because 1/12 of 360 is 30 degrees. Okay, this is in the book too, if the way I'm speaking is kind of going over your head. Okay, so at 1 o'clock, if you had, I'll just show you, if we had a straight up and down, at 1 o'clock, that's 30 degrees, right? At 2 o'clock, the angle becomes 60 degrees. 3 o'clock is 90 degrees. So, you know, we all kind of can see that this would be a 90-degree angle, okay? And this would be 6 o'clock would be 180 degrees, right? And so on. So the big question is, how many degrees is there in a minute? Okay, so let me draw you a picture. Or let's do like, what's the angle? This would be in the book. What is the angle we make here? We can estimate and then find the actual. Okay, so this, and we can find the actual without actually measuring it with this. I just use that as a straight edge. So how do we find out how many degrees are in there? Well, we have, like we said, this was 30 degrees, right? How do we know that? Well, if there are, how many minutes in this hour? 60 minutes, right? So each minute is how many degrees? Well, let's do 360 divided by 60 minutes, and that tells us that each degree or each minute is 6 degrees, right? So if we have 1, 2, 3, 4, 5, 6, 7, 8 minutes represented here, right? 8 minutes. How many degrees is that? Well, 1 minute is 6 degrees. So 8 times 6 degrees equals 48 degrees. So we just found out the angle measurement there is 48 degrees. We can check it on, I can use my protractor and see how good we got. Now this doesn't go all the way out, but if it did, it looks to me like my protractor's upside down. But I do believe we are, yep, we're just shy of 50, so 48 degrees. And you can't even see what I just did there, sorry. I'm trying to do these in a hurry. Shouldn't do that. So there it is. Not 50, but 48. All right. But, like I said, we know how many degrees are in a minute because we can do the math. And that's exciting. So, let's look at example 1. Estimate the measure of BOC down here in the figure below. It says use the protractor to find the measure. Okay, and then use a protractor and then check the difference. Okay? So, if we estimate, so we're looking at this angle here. Okay, one thing they give you a picture of looking at it on a clock. Okay, I kind of like to look at it where this is horizontal with my sight line. So I can tell it's not quite 90 degrees, right? I'll show you. That would be 90 degrees. So it's just shy of 90 degrees. 45 degrees is perfectly in between 90 degrees. So, I don't know. I'm going to say 80 degrees would be my guess. So, estimate 80 degrees. Okay, then use my protractor to find the measure of it. You may do the same. Now, here we are. I'm going to measure that up. I'm not liking the protractor that I've provided my daughter because it does not give individual degrees, it just gives by 5, so I don't like that. So it looks to me like I am at, not quite 80, but close. I'm happy with myself. I'm about, 78 degrees. So use a protractor, 78 degrees. And how many did I differ? I differed by 2 degrees. You might get something different, okay? And that's all right. In the book, they differed by 3 degrees. So when you estimate, you're dealing with the naked eye, just trying to guess. But it's good to get things pretty close or get a good idea of whether or not it's greater than 90, less than 90, around 45, and so on. And whatnot. And so not, whatnot. Okay. So now we've got a new concept. So set your protractor aside, and this concept is called, I want you to write it out because you're going to use this so much. I want you, the distributive property. And they even call it the distributive property over of multiplication over, this is an exciting word, and then we're doing addition. Multiplication property, or the distributive property of multiplication over addition, meaning we're spreading multiplication over addition, okay? And what the property says is, if you were to multiply something times a sum, you could also break it up, and I do this with mental math all the time. Instead of finding the sum first, you can take the outside factor and multiply it by one of the first inside guy and the second one. So it's A times B, A times C. Here's another visual. That's how my teacher always showed us. You can take this A and multiply it by the B and add it to the product of the A times the C. So a plus b, a times c, added together. What does that mean in real numbers? Okay, let's look. Well, these aren't real numbers, this is some variables. But now we're going to unpack this and expand it. Okay, we call that expanding using the expand using the distributive property. So I'm going to take my 2, multiply it by the x, and then multiply it by -3, because that is not a +3, it's a -3, because he gets the sign of what's in front. So 2 times x is just 2x. And 2 times -3 is -6. So we end up with 2x minus 6. So 2 times x plus 2 times -3. And it looks just like that, okay? Next one, same idea. Now we multiply a -2 by x and by +3. So -2 times x is -2x. -2 times +3 is -6. And there it is. Thus, that is the answer, as goofy as it looks. Okay. How about this one? We do -2. This one's going to be, this is trickier because we're going to do a negative times a negative. So -2 times x is -2x. -2 times -3, when we have an even number of negatives multiplying together, they become positive. And we get -2x plus 6. Okay, oh, this one's different because out here is a letter and in here is a letter. They're variables. So what does it mean to multiply x times x? X times x is x squared. Okay, x times -3 is -3x. Okay, I want you to absorb that, okay? Really soak that in and make sure you understand. Okay, so these ones were kind of straightforward. Now they're going to throw more at you. Kind of feel like you're drinking from a fire hose? I do. Okay, so it says simplify. Now we always get rid, when we simplify this variable expression, we want to get rid of a parenthesis first. So we have to use the distributive property to get rid of this parenthesis. This was in a worksheet I gave out last week. And now we're going to address how to do those. Okay, so there's nothing we can do yet. These two just need to come down to the next line to wait their turn. And now we're going to deal with the 3 times x and 3 times -2. So 3 times x is plus 3x minus 6. Okay, so now we've got rid of our parentheses, and now we combine like terms, or I only see one pair of like terms. I see it right here and here. So those get to simplify or join up. Everyone else is kind of alone. X squared stays there. 2x plus 3x is plus 5x. 2 plus 3, right? Minus 6. And what we end with is a trinomial. Okay? Alright, so I know this is new, and it was on that worksheet. So if you still have that worksheet, I encourage you to go back, and I will give extra credit for anyone that turns in those last, I believe, 5 problems using the distributive property in your worksheet. If you want that worksheet back because you want that extra credit, I'll actually upload it to the cloud and make it available for you, okay? If you want extra credit option. Okay, now some of you did it already, and just send me a little text or email that you had done it, or I know some of you. I know McKenna did it. I'm going to write some of your names down. I know Annalise did these already. I'm not sure who else did. I think maybe Avery, okay? So you 3 girls, I've seen yours. The rest of you, please notify me if you did the extra credit and I just didn't see it yet, or bring it back to me and get extra credit, okay? If you haven't thrown it away, which I hope you haven't. All right, now you get to pause and go ahead and do your practice and come back and see how you did. Okay, by counting minute marks on the clock face below, find the measure of each angle. So AOB Ooh, that's a little one. And so we've got, looks like we've got 1, 2, well, 4 times, what did we say? Each 4 times 6 degrees. So 24 degrees, right? AOC, well, that looks like we've got 20 times 6 degrees, so 120 degrees. AOD, looks like we got 5, 6, 7 minutes, so 7 times 6 is 42 degrees, right? So where did I get the 6 degrees? It was on our first page of this of the packet, in case you're wondering where I got that. Okay, in this practice, we're going to estimate the measure of each angle, then use a protractor to measure them. By how many degrees did your estimate differ from your measure? Okay, so I'm going to look at BOC. BOC, and like I said, I like to look at it like that and kind of see where 90 degrees would be. So I'm going to take away like, I don't know, 20, 25 degrees. So maybe, and if out here would be 45, so 65 degrees is my guess. Okay, and then I'll call that E for estimate and A for actual. So the actual was 60 degrees, and the difference, 65 minus 60, was 5 degrees, okay? So we're going to do the same thing with E. My estimate is for DOC. Okay, I like to turn it around. Ooh, and I see it's less than 45, because I'm going to say, so maybe I'm going to go ahead and say 20 degrees, okay, DOC. My estimate is 20 degrees. Actual is actually, I can see what I'm doing here. The actual is not quite 20. So okay, it's more like, wish I had actual degrees on here, but it looks like it's going to be like 17. Okay, so I'm even having to estimate my actual because this doesn't have it down to degrees. All right, so my difference is 3 degrees. Now your answer key might be different, or the answer key might be different than my actual, because like I said, my tool is not precise enough. Okay, so FOE, F-O-E, we're going to look there, and to me, I'm looking at it, and that totally looks like 45 degrees. Okay, so that's my estimate, is 45 degrees. My actual is, let's see, oh, more than 45. It looks like it's 48. Okay. So the difference is 3 degrees. Okay. So the idea is you want to get these within, 5 degrees, 10 degrees. Try and get good at estimating within 5 or 10 degrees. It's really the whole purpose of this. Okay, so now it's FOB. So we've got an obtuse. Oh, I'm supposed to guess first. So I actually knew that BOA. Do we know what BOA is? AOB? I thought we did. I guess not. Oh, I guess we know BOC. So I'm going to say this is about 40 degrees. So if we take 40 away from 180, I'm going to say my estimate is 140 degrees. Actual is 150. So I was 10 degrees off. Okay. All right, now I'll switch gears. These will go faster. We're doing the distributive property. And so we're going to multiply that through. So it's x times x is x squared, and x times negative y, so we say minus xy. Okay. Negative 3 times 2x is negative 6x. Negative 3 times negative 1 is positive 3. Okay. Negative x times x is negative x squared plus 2x. Okay. Negative 2 times 4 is negative 8. Negative 2 times negative 3 is plus 6x. Okay. And now we got to take care of parentheses first. So these two just come down and get ready to play on the next step. So negative 3 times x is negative 3x. Negative 3 times positive 2 is negative 6. And now we combine the like terms, which I have here, and we have a plus 2 and a minus 3 x's. So it's x, so that makes it a negative 1x or minus 1x. So I'm just going to say minus x minus 6. Okay. And this one, again, these two just hang out and wait. Negative 3 times x minus 3x, and that's a plus 6. Negative 3 times negative 2. Combine our like terms, minus 2 and minus 3 is minus 5x. So x squared minus 5x plus 6. And there we go. That's the end of it. So I was making sure that was it. Okay. And we will see you on the next.